In the last video, you saw me use the HtDF design recipe to design a very simple function. But I went through it very quickly, too quickly for you to absorb the different elements of the recipe. What I'm going to go through in this video is the same design much more slowly and talk more carefully about what I'm doing at each step. What I recommend you do is have your computer open up Dr. Racket and follow along with the design recipe as I'm going through. At each step, you could stop the video and catch up in your Dr. Racket. And I also recommend that you open up a web browser to the HtDF design recipe page from the course website so that you can follow along with that as well. Then you'll be able to see what I'm doing and practice it as it's going through.
Just like before, I've taken the doublestarter.racket file from the week 1 webpage. I've opened it up, and here's the problem. We're supposed to design a function that consumes a number and produces twice that number, and the function should be called double. Again, it's a very, very simple function. Remember, we're using simple functions to learn the recipe, and then the recipe will let us do harder functions. And also, just like in the full speed version of the video, I've taken a copy of the How to Design Functions recipe, which I got from the Design Recipes page, and I've set it here on the right-hand side so we can refer to it as we go. The first step of the recipe is to write the signature. The job of the signature is to tell me what type of data a function consumes and what type of data it produces. In this case, the function consumes a number and produces a number, so I write the signature with 2 semicolons, a space, capitalized number, type names are always capitalized, and then I make a little arrow, and again capitalized number because this function produces a number. If the function consumed multiple arguments, then I'd have multiple type names before the arrow. In this case, it just consumes one argument, and I read this signature as saying the function consumes a number and produces a number. Now I need to write the purpose. The job of the purpose is to give me a succinct description of what the function produces given what it consumes. So in this case, a good purpose is to say that the function produces 2 times the given number. Now I know exactly what it's producing in terms of what it consumed. The purpose needs to say more than the signature. So a purpose, for example, that just says consumes a number and produces a number isn't telling me any more than the signature, and that wouldn't be a good purpose. We also want the purpose to be short. Sometimes it's hard to write it short, less than 1 line, but it's good to do so because it starts to help you understand the function. And the stub is like a piece of scaffolding that we're going to put in place for a short period of time. It's going to help us with some other parts of our work, and then we'll end up commenting it out, or later in the course we'll just actually delete it. So it only lasts a short while, but it will do an important piece of work. What the stub has to be is a function definition that has the correct function name, in this case double, has the correct number of parameters, in this case 1, I'll just call it n, and it produces a dummy result of the correct type. Since this function produces number, I'll make the stub produce 0, because 0 is certainly a number. So now I'm going to write the examples and tests. We call them examples and tests because they're going to serve both roles. What I mean by examples is that oftentimes it's easier to design a general function if we start with some very specific examples of what it's going to do. So in this case, for example, I might write check expect that if I call double with an argument of 3, then what I expect to get back is 6. And I'll also write check expect that if I call double with an argument of 4.2, I'll expect to get back 8.4. The reason I'm calling double with these 2 arguments, the reason I have 2 examples, is I've said here in the signature that the function consumes number. And by number I mean real numbers, integers, natural, all kinds of numbers. And so I'm going to put 2 examples here just to really illustrate that I don't just mean integers. The first example might lead you to think I just mean integers. We're going to talk a lot in the course about reasons to have multiple examples and how many examples are enough for a given function. But here's two examples for this function. Because I've wrapped them in check expect, they're also going to be able to serve as tests. And we'll see shortly how they're going to help us code the final body of the function. But first, what we're going to do is make sure that the examples, that the check expects, are well formed. And here's where the stub's going to help us. What I'm going to do now is I'm going to go ahead and run this program. And when Dr. Racket has a program that has check expects in it, what it does is it runs the check expects, and it checks to see, for each check expect, it will call double with 3, and it checks to see whether the result is 6. And then it will call double with 4.2, and checks to see whether the result is 8.4. And if the result isn't what it's supposed to be, then Dr. Racket reports that the test failed. Now in this case, both tests failed, and I'm very happy. The reason I'm very happy is both tests actually ran. Here's what the stub is doing for us. It's letting us make sure that the tests actually run. They're going to fail because the stub always produces 0, and that's not the right answer for these cases. But we're going to know that they ran. And you'll see later as programs start to get big that making sure all your tests are well formed before you get farther along in the process is a good thing to do, because the sooner you find a mistake, the easier it is to fix. So here we go. Both of these tests ran and they failed, and I'm really happy. I want to take a minute here to make an important general point about the recipe. And that is that every step of the recipe is intended to help with all the steps after it. For example, the signature helps us write the purpose, because the signature tells us that the function consumes a number and produces a number. Similarly, the signature helps us write the stub, because the signature says the function consumes a single argument, so this function has one parameter. It's a number, that's why I called it n. It also tells us that the function produces a number, that's why I chose 0 as the dummy value for the stub to produce. The signature also helps us write the check expects. It tells us that this function, when I sit there and write check expects double, and then I ask myself what to put, well, the signature tells me put a number. And then when I try to write the expected value, the signature says that it's a number, and the purpose tells me exactly how that number relates to the argument in the example call. The key thing is when you're trying to figure out what to write at one step of the recipe, look at what you wrote at the previous steps of the recipe. That's how the recipe is helping you, is it's letting you slowly build up the knowledge you need to design the final function. The next step of the recipe is the template, or sometimes called the inventory. Starting next week, we're going to get richer and richer templates. But for this week, the template is going to be quite simple. The template is a function with the right function name and the right parameter. And for this week, the body of the template is just going to be open paren ... n. And the way we're going to read that is we're going to read that as saying, hey, the outline of this function is that it's going to do something. That's what the dots mean, is do something. It's going to do something with the parameter n. That's the role of the template, is to give us kind of the outline of the function. What I'm going to do here is label the template. And now I'm going to make a copy of it. I'll put the copy here. I'll remove the label from the copy, and I'll comment out the original template. What you're going to do later in the course is you're not actually going to keep a copy of the template. But we found for the first few weeks of the course that it helps to keep a copy of the stub and template around. And that's why that's what I'm doing here. There's the template. It's the outline of the final function definition. Now I'm going to code the function body. In this step, I'm going to use everything I've written before to help me know how to finish the function body. One thing that's useful to do sometimes is elaborate the examples. So in this example, I know that double of 4.2 is 8.4, but what I'm going to do now is make it more clear to me why that's true. The reason that's true is that it's times 2 of 4.2. And now all at once I know exactly how to finish this function body. It's just times 2 of n, whatever n is. The last step is to run the tests. So I run the tests here, and I get both tests pass, which makes me pretty happy. We'll see examples later about what to do when the tests don't pass.
Now you've seen the HtDF design recipe used twice to design the same simple function. In the last video, I went through it quite quickly. And in this video, I went through it in slow motion where I talked in detail about each step. At this point, you should be starting to understand what to do at each step of the design recipe. If you feel comfortable with that, then I would suggest you go ahead to the next video in which we'll work another HtDF design problem together. If you don't necessarily feel comfortable with it, then I would suggest that you take a blank editor tab and rework the process of designing the function from this video on your own step by step. But when you do it, do be sure to have the HtDF design recipe page from the website open. Use that as a reference whenever you're using the HtDF design recipe. Our goal is not for you to memorize the recipe. Our goal is for you to learn how to use it as a resource in designing increasingly more complicated functions.